Hello guys, good evening, and this is Dr. Pooja, and today we will talk about periodic table. Okay, so I see Neeraj Gupta has joined, Diksha has joined. Let me decrease the volume. So hi all. So guys, today's topic is very interesting. The reason being, when we learn science, when we talk about science, when we talk about chemistry, how can we forget about periodic table, right? So on this Unacademy's platform today, I have picked this very interesting topic, which is understand the periodic table with me. All right. So we will talk in details about how the elements are arranged in our periodic table. All right, so let's get started, and I hope you guys will love it. And before I get into the details, I would love to explain a little bit about myself. So guys, my name is Dr. Pooja, and I was a scientist in United States of America for almost 8 years. I have done PhD in biotechnology, and now I'm an online fitness educator, fitness coach, and science educator on Unacademy's platform. Okay, so if you want to learn science with me, if you want to learn physics, chemistry, and biology with me, please feel free to join me on Unacademy, and I will take care of your science. Okay. And here are the options. If you want to go for a plus subscription on Unacademy, here are the options. And first of all, why you really need to go for Unacademy. The thing is, just hold on, where is my mouse? Yes, here you go. So here you don't have to go anywhere. You will learn from the comfort of your house. You don't have to go anywhere. Unlimited access to the courses, because all the courses are saved for you. And we have on Unacademy's platform top educators from all over India, and they will be taking care of all the important subjects. Like I'm taking care of your science, and there will be people who will be taking care of your mathematics, your English, your SST, and all other different subjects. All right. And here what we do, we cover your syllabus, and not only we cover your syllabus, we have regular doubt clearing sessions, we have live test series, then and don't worry, I mean, if you forget by any chance to attend your class, we have all the study material saved in FB PDF format, and we have all these answer writing sessions. And let me see who have joined us. Gaurav, this session is for English students. So I will talk about periodic table in Hindi, but as I said, this is for English, as I'm an English educator, so I would prefer to deliver this lecture in English, but I will make sure the things are pretty clear to you. See, this is periodic table, so I'm not going to talk about any difficult English. Reason being, I will only talk about the elements and how they are put together to make a periodic table. All right, so this is like all the Arya. Welcome to my session. So good job, guys. Ojasvi is also there. Hello, hi, Ojasvi. So guys, today, as I said, I will be talking exclusively about periodic table, because as you know, periodic table is very important part of your science, your chemistry. You must know about the periodic table. Okay, so here we have ongoing batches, and there are our upcoming batches, so you can be part of any of these. And here are the details of the subscription. You can go for 1 month, 6 months, but I would recommend you guys to. Hello Shara, how are you? Ojasvi is there. Hi guys. I would recommend you guys to go for 36 month subscription, because that is the best and most economic plan that you can get. And here is my code PS13. If you want 10% extra discount on the same, go ahead and use my code. Okay, and this is all about the subscriptions. So are we ready? Tell me, are we ready? Ready? If you are ready, show me your thumbs ups, and then I'll get started with the periodic table. Okay, So guys, here we have, I'm fine guys. So here we have our beautiful looking periodic table. So if we will talk intensely. Hansa, I know this is India, but the thing is, as I said, I'm your science educator, and on Unacademy, I will be teaching in English. But if you have any questions, any queries, ask me. Okay, I'll be more than happy to answer all your questions in Hindi. But the thing is, ये जो मेरी class है, ये English students के लिए. English students means जिन्होंने subscribe किया है for they have pegged English as a preferred language. Okay. All right. Okay, Hansa, that's fine. I mean, if you want to learn. If you don't want to learn, you may leave. Okay, that's okay. So guys, so this is the periodic table, right? So what you see in this periodic table, we have our 118 elements that we see around us. They are arranged in this periodic table. Okay, and I will not get into the details of like how we came to this periodic table. I will not talk about the history and how many scientists they started with the triads and all those things. We'll just talk about like how periodic table, how the elements are arranged in periodic table. So in one word, I would say they are arranged in the increasing order of their atomic number. Okay, so the elements present. Hello Yash, how are you? So elements are present in the periodic table and in the increasing of order of their atomic number. Okay, so if I tell you like all these elements that we see here, what are these symbols tell you? Like H, L, I, Na, you know. So okay, Yash, welcome to my session. Okay, so all these symbols, so let me go to the next slide. Yes, here you go. So guys, in the periodic table, as I said, we have all 118 elements arranged, okay, in the increasing order of their atomic number. Okay, that is what the periodic table is. But when we look closely at the periodic table, what we see? Okay, great. So what we see, this is the symbol, atomic symbol of the element. Okay, and what we see over here is the atomic number. So I have talked about atomic number in my many videos and classes that I take with you guys. So atomic number is actually the number of protons, or I would say the number of electrons which are present in an atom. Okay, that is the atomic number. And I would add here that the atomic number, that is what I would love to say here is, atomic number is the, I would say, I card of the element. Okay, every element is having a unique atomic number in the periodic table, which means every element in its neutral state, I would say, will always have a fixed number of protons and fixed number of electrons, and depending upon that we give it a atomic number. So guys, this is the most important point when we talk about modern periodic table, because in the modern periodic table all the elements are arranged in the increasing order of their atomic number. So आपको ये याद रखना है कि atomic number है या atomic mass है. So here is at the bottom is atomic mass. And what is atomic mass? All of you know it. Atomic mass is the total number of protons plus neutrons present in the nucleus. That is the atomic mass. So initially, if I go a little bit about the atomic masses in the previous periodic tables, they say the periodic table is arranged, or the elements are arranged in the periodic table as per their atomic masses, which is not acceptable now. We now say that it is the function of the they are arranged as per the atomic numbers. All right, so this is about, like, if we say how and what these elements are. Okay, so now let me erase this real quick. Okay, and now we will see what are these. So now we have understood, like, all the elements that we see, they are having like hydrogen, lithium, beryllium, sodium, magnesium. All these are the symbols, and in the periodic table they are given the number. Here is the atomic number, and over here is the atomic mass. Okay, hi Hemlata, welcome to my session. So this is clear, like all 118 elements, they are arranged in the increasing order of their atomic number, and these symbols are given, their atomic numbers are given. Okay, from there we can get an idea, like this is the number of electrons present in this particular element. Okay, so next point is, if you look at the periodic table carefully, we see there are rows and there are columns. So what are these rows and what are these columns? Hello Anuj Prajapati. Oh, welcome. So what are these rows and what are these columns? I will talk about it real quick. Okay, I'm good, thank you. So if you look at the periodic table, you will find they are numbered like 1, either you can number them 1, 2, 3, 4, 5, all the way to 6, 7. So these are all columns. 8, 9, 10, 11, 12. Then we have 13, 14, 15, 16, 17 and 18. So these are the groups. So in periodic table, first thing you have to remember, we have 18 groups, and if you look at this, we have 1, 2, 3, 4, 5, 6 and 7 periods. Okay guys, so this is again important thing to remember. There are 18 groups and 7 periods in our periodic table. And how about these two then? Okay, how about these two? If there are 7 periods and 18 groups, why are we having these 2 rows over here? What are these? Actually, they come from here, lanthanides and actinides. And why we have placed them at the bottom? To keep the symmetry of the periodic table. Because if we include all these over here, our periodic table will expand and we will not be able to see all the elements in one screen. So that is the reason it has been placed at the bottom. Okay, so now quickly I will erase this off and hold on. Yes, so now I will say, as I said, they are grouped as 1 through 18. So that is the one way of grouping all the elements together in the periodic table. And there is another way we can do that. We can group them as, if you see, 1A, 2A, and for now let's forget about these elements and directly we'll go on to 3A, 4A, 5A, 6, 7 and 8. So this is the easier way . Yes, we got connected again. So guys, yes, here we were talking about, how these groups and this valency, they are related. So I was telling you guys, I'm sorry. Okay, I was telling you guys, like whatever the number of group is, whatever the number of the group is, that is going to be the valency of that particular element or particular group. Okay. Yes, for example, let's take an example of lithium. Okay, I will keep on explaining the things so that there is no confusion. So let's say we have lithium, and the atomic number of lithium is 3. So what do we mean by that? If the atomic number is 3, as per the rule, we all know what octet rule is. As per the octet rule, every element is going to have 8 electrons or 2 or 8 electrons in the outermost shell. That is the octet rule. So if we have lithium, so its atomic number is 3 and its electronic configuration 2 and 1. So here is the 1 valence electron for lithium, and lithium falls in group 1 here we see. And if that is the case, so let's go and talk about helium in this case. In helium, or let's say neon, we'll take example of neon. So in case of neon, the atomic number is 10, and if we talk about the electronic configuration here, it is 2 and 8, and here is the valence electrons. So that is what, as per this new grouping convention, or as per this new method of grouping the periodic table, as we are doing 1A, 2A, and then we neglect these and we go to 3A, 4A. Whatever the group number is, that is the number of valence electron. Okay, that is another thing that you will have to remember from this class. Okay, so helium is having 8 valence electrons. So I hope this is also clear to all of you. Now I will move on to the next section, like how these elements are grouped. Okay, so if we, I'm sorry, it didn't get erased, give me a second, hold on. Okay, now let's talk more about let's talk more about like how we are grouping all these elements together, and I'm gonna color them. Let me see if I can highlight them. So let's go to group 1 first. Okay, so here in group 1 we have all these elements. Okay, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so these elements we also call them alkali metals. Okay, so the elements present are called alkali metals. So why these are called metals? Okay, this we will talk more about in details in upcoming slides, but metals are the ones which are electropositive in nature. More electropositive in nature means easily. Thank you so much, Yash. Thank you. Easily it can lose electrons. So if somebody or something can lose electrons, that means it's electropositive in nature. And if something is electropositive in nature, that means it is more metallic in nature. Okay, so that is why we call all these elements in this group 1 over here, these are all alkali metals. Okay, so group 1, I will just shade it maroon over here. These are our alkali metals. So I will cover the whole periodic table this way. I will go over the whole periodic table, like what are the elements and what do we call them and all those things. Okay, so next we will move on to group number 2. In group number 2 we have beryllium, magnesium, I will highlight it again, beryllium, magnesium, calcium, strontium, barium, and radium. Okay, so these group 2 elements are called alkaline earth metals. Okay, so these are also metallic in nature, but we call them alkaline earth metals because the metals in group 1 that we have just discussed, the metals in group 1, these are very reactive metals. We don't find them in free state in nature, these metals over here. Okay, we don't find them in free state in nature, so that's why we call them alkali metals. Alkaline earth metals are little stable as compared to alkali metals, and they are also found in nature in the form of groups. Okay, they are compounds with some other more reactive elements. So now this is our group 2, and these are also metallic in nature, but we call them group 2 are called alkaline earth metals. Okay, so this is our group number 2 over here. So group 1 and group 2, we are having all metals in nature. Okay, so next comes our, if we move on to the next group, all these from here, like whatever I have shaded here, just a second, these are all metals, these are all our metals. Okay, I will also talk about like these two, we are called S group, these are called P block elements. This is called over here D block elements over here, and the ones under here are called F block elements. Okay, hello Ashish, how are you? So now we have talked about, metals are here and metals are here. Now let's talk about, let's go to the end of the periodic table. If I go at the end of the periodic table, let me pick a color over here. So group 8, if I pick group 8, so what do we see? Let me take another color real quick, light blue, because this is going to be little dark blue. Okay, so let's see if I talk about group 8, just a second. Okay, if I talk about group 8, that means it is going to have 8 electrons in the outermost shell, and if it is having 8 electrons in the outermost shell, it is not very reactive because all the valencies are complete. Okay, so all these elements that we have, I will shade it blue, all the elements that we have, helium, neon, argon, krypton, xenon, radon, and argonston. So these all elements are, we call them inert gases. Okay, so we call them, I know this look little cluttered, but this is the way we can go over the periodic table, and at the end I will show you a very clear picture. Okay, so don't worry, like you will have to remember this this kind of periodic table. I have a much better, even a better picture of this periodic table, don't worry. Right, and then over here, so these are our inert gases, so these are also non-metallic in nature. And if I take another color and let me take little green in color. If we take this fluorine, chlorine, bromine, iodine, acetylene, and tennessine, so all these elements that we have, we call them halogens. So over here we have halogens. What are halogens? First of all, they have 7 electrons in their outermost shell, and if they have 7 electrons in the outermost shell, that means their valency is 7, and they can take 1 electron to complete their octet. So which means they are salt forming. Halogen means they are noble gases at the end, Anuj, right? So these are salt forming elements: fluorine, chlorine, bromine, iodine, acetylene, and tennessine. So now we have all these covered. All right, and now another interesting point which I would like to share with you guys is, let me take another color. Maybe I cannot see it is okay. Let me pick another color for you, and let's take light green. So the elements which are we going to have here, you will see a zigzag, right? So this element, right? So these elements that we have over here, these are called metalloids because they have the properties which are mixture of metals and non-metals. So what we call them, these are called metalloids. Okay, so now what we are left with, if we let me erase it a little bit. Hold on, guys. Trying to erase it. Okay. Hello, Krishna. I'm sorry, it all got erased. So quickly, I would say, so these were our metals, right? Somehow it got erased. I'm sorry about that. And here we had our, let me take another color. Here we had our non-reactive elements, and then here we had our halogens. This is very important to understand actually. And then in the middle, these are also all our metals. Okay, guys. So because this grouping of elements is super important that you need to understand. Okay, so these are all metals, and then here we drew line over here, which are our zigzag line, and it divides our metals from our non-metals. Okay, so this right, so whatever I have shaded yellow, those are metalloids. Okay, now let's see what all these some more metals are here. So these are over here, some more metals that we have. Okay, and now we are left with couple of elements that I will shade, let's say purple. So we have CHNOPS, CHNOPS. So here we have CNOPS SE, and we will also consider H in this category. Okay, so what are these? So these are also non-metals, are the ones which are very important part of human body. Hello Lakshay. Okay, so all these elements are carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. So these are very important. Okay Lakshay, welcome to my channel. So these elements are very important part of our carbs, our proteins, our fats, our vitamins, right? So these elements which I have colored purple, they kind of make important components of human body. Okay, so now what I'll do, so this is I covered like all the elements, how they are grouped together. Okay, let me show you. So there will be couple of blank slides. I will explain things over here. So here you go. Okay, so this is the colored remember, and it will help you to take care of all the important points that we have. So quickly, very good evening Subhash Yadav. Quickly I will say the red elements over here, from here to here, are your alkali metals. From here to here are your alkaline earth metals. Okay, so all these yellow ones over here are your transition metals. Okay, and then we have more metals over, then we move on. People think these are all from here to here noble gases, and these are your halogens over here. Okay, so your halogens are covered, your noble gases are covered. Okay, then you covered your metals, your transition metals. Okay, and then this over green, these are more metals. All right, over here, aluminium, gallium, right? And the one which I just drew in my back slide, this one, this zigzag line, it covers the metalloids. Okay, and here is your C and H and NO, P, S, SE. So these are your main non-metals. Okay, so this was quickly about the periodic table, and I almost forgot about lanthanide and actinides, which are at the base, because we cannot try to fit them here. This will elongate the whole periodic table, okay, and which will not make any sense. Now let's talk about quickly trends in the periodic table. Okay, as I said, when we move in the periodic table, the properties of the elements are the periodic function of their atomic numbers. So as you will see in this periodic table, every next element is having one extra electron as compared to the previous one. Okay, so that means in the periodic table, all the next element is having one more electron than the previous one. Okay, so now let's talk about the trends in the periodic table. So the major trends that we will discuss in the periodic table is, let me show you real quick. We will talk about atomic radius, electronic affinity, and ionization energy. Okay, and I left those slides over there for this purpose only. There were a couple of blank slides. So let me go to these blank slides here. So now first we will talk about the atomic radii. How big the atom is, how the trend is in the periodic table if we talk about atomic radii. Okay, so here what we will do, I'll just take an example of lithium, sodium, potassium, rubidium, cesium, francium. Okay, and if we go, हिंदी में बता देती हूँ सुभाष, देखिए अब हम डिस्कस करेंगे कि एटॉमिक रेडियस जो होता है एक पीरियोडिक टेबल में वो कैसे चेंज होता है, राइट? सो लेट्स डिस्कस दैट कि अगर हम अलोंग द पीरियोडिक टेबल मूव करते हैं तो उसका एटॉमिक रेडियस में बढ़ेगा या कम होगा या कैसे होगा. ये जब आप एग्ज़ाम में आता है तो आपको एमसीक्यूज़ में भी आएगा कि उसका साइज़ बढ़ रहा है, छोटा हो रहा है. एटम का they will have a question like lithium is bigger in size or francium is bigger. ठीक है, तो उसको अंडरस्टैंड करने के लिए let's have this session quickly. I will talk about the trend of atomic radii in periodic table, and we will talk about how the atomic radii it changes when we move in a group or when we move in a period. ठीक है, ये दोनों चीज़ें हम डिस्कस करेंगे. तो अगर तो वी आर मूविंग डाउन लाइक दिस, सो दैट इज़ वी आर मूविंग इन अ ग्रुप. एंड अगर हम इस साइड को मूव कर रहे हैं दैट मीन्स वी आर मूविंग इन अ पीरियड. ओके, सो अगर हम इस साइड को जा रहे हैं, लिथियम, बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, नियॉन. ओके, आई एम सॉरी, नियॉन. ठीक है, तो आप इसमें देखो कि इनका एटॉमिक नंबर क्या है. लेट्स हैव देयर एटॉमिक नंबर रियल क्विक. अभी इनका एटॉमिक नंबर है, लिथियम इज 3, 11, 19, यहीं तक करेंगे. एंड इफ यू गो दिस साइड, 3, 4, 5, 6, 7, 8, 9 and 10 guys. Okay, so this is in blue is the atomic number. We will not talk about these because this is going to be a little confusing. बहुत ज़्यादा बड़ा हो जाएगा, तो we will just talk about this. So if we are moving down the group, what is the trend in atomic radii? And if we are moving along the period, what is the trend in atomic radii? कैसे होता है वो, बढ़ता है, छोटा होता है, how it works? Okay, तो पहले तो लिथियम का है, atomic number is 3, its electron configuration will be 2 1. Beryllium की electronic configuration 2 and 2. Boron will be having 2 3. Carbon will be having 2 4. Okay, मैं बायोलॉजी भी पढ़ाती हूँ, मैं सब चीज़ पढ़ाती हूँ. ओके, फिजिक्स केमिस्ट्री बायोलॉजी सब पढ़ाती हूँ. 2 5, 2 6, 2 7 and 2 8. So this is the electronic configuration अगर हम इस साइड को मूव करते हैं, स्टार्टिंग विद लिथियम. और सोडियम का क्या रहेगा? 2 8 1. पोटेशियम का क्या रहेगा? 2 8 8 1. So if we see, because electronic configuration plays a very important role when we are talking about, the size, the radii of the element, of an atom. तो कैसे होता है? अगर इसी चीज़ को हम एक डायग्राम में रिप्रेजेंट करें, सबसे पहले we will start with this lithium, कि ये तो हो गया न्यूक्लियस. ठीक है, न्यूक्लियस के बीच में आ जाएंगे आपके प्रोटॉन्स एंड न्यूट्रॉन्स. आई एम नॉट ड्रॉइंग दैम. And these are the shells, right? It will have, I will draw the electrons with different color maybe. So it will have 2 electrons and 1 electron, right? When we are moving this way. So this is in case of lithium. But let's say in case of boron, what will happen? Another electron will come. एंड मैं पढ़ाती हूँ सुभाष 8:45 पे एवरी डे ऑन अनअकैडमी के प्लेटफॉर्म पे. आप वहाँ पे आके पढ़ सकते हैं. माई नेक्स्ट क्लास इज़ ऑन अनअकैडमी. एंड गाइज, आपके लिए इज़ अ गुड न्यूज़. आप अभी अगर जा सकते हो तो अनअकैडमी पे जाओ. ठीक है, वहाँ पे आज मेरी स्पेशल क्लास है एंड दैट इज़ ऑन फिटनेस. आई एम अ फिटनेस कोच एज वेल. ठीक है, तो वो स्पेशल क्लास है रात को 9 बजे. फ्री क्लास है, आपको सब्सक्रिप्शन लेना ज़रूरी नहीं है उसके लिए. ठीक है, दैट इज़ माई फ्री क्लास. आप उसमें आके देख लेना. तो बी पार्ट ऑफ दिस स्पेशल क्लास ऑन अनअकैडमीज प्लेटफॉर्म. ठीक है, तो आप अगर आपको अच्छा लगता है तो मैं अपना टेलीग्राम लिंक भी शेयर करूँगी एंड देन आप मेरी सब्सक्रिप्शन भी ले सकते हो. ठीक है, तो दिस वॉज अबाउट बोरोन का क्या स्ट्रक्चर होगा. There will be 1 extra electron. And if you talk about beryllium, and then if you talk about boron, there will be 3 electrons. Carbon, there will be 4 electrons. Nitrogen, another electron. Oxygen, another electron. So guys, you see, when we are moving in a period, our shell is staying the same. Same shell is there. And we are adding electron to the same shell. Addition of electron to the same shell में ही add हो रहे हैं सारे के सारे. Hello Sharam. ठीक है, तो क्या होता है कि when we are moving in a period, we are adding, तो यहाँ पे ये 7th electron for fluorine, and when we move on to neon, there will be extra electron. Okay, so lithium से लेके neon तक when we moved, all the electrons they got added to our second shell. ठीक है, तो इससे क्या हुआ? From here what we will learn, like in a period the shell is not increasing, the shell is staying the same. Okay, and the nucleus is attracting the electrons present in the same shell, right? So इससे क्या होगा कि as we are moving from lithium to neon, बायोलॉजी हिंदी में पढ़ा दूंगी. ठीक है, हेलो स्पर्श, पढ़ा दूंगी आपको हिंदी में. ठीक है, तो साइज जो है इसका वो होगा डिक्रीज. ओके, अगर आप जा रहे हो पीरियड में फ्रॉम लेफ्ट टू राइट इन अ पीरियोडिक टेबल, वो मैं अभी आपको पिक्चर में भी दिखाऊंगी. ठीक है, अब मान लीजिए आप जा रहे हो डाउन द ग्रुप, ऐसे ग्रुप में, हर ग्रुप में डाउन जा रहे हो, तो उसमें क्या होगा? ठीक है, अभी एक टाइम के लिए मैं इसको आई विल बी इरेजिंग इट, इसको मैं एक बार इरेज कर देती हूँ, ठीक है, क्विकली। एंड आई विल ड्रॉ कि लिथियम से लेके पोटासियम तक जब हम जाते हैं, हाउ द साइज वेरीज, ठीक है, हाउ द साइज ऑफ द एटम इट चेंजेस। लेट्स टॉक अबाउट इट रियल क्विक। सो हियर आई विल शो यू। अब हम जाएंगे अलोंग द ग्रुप। ग्रुप में क्या होगा, डाउन द ग्रुप क्या होता है। सो वी विल टेक एन एग्जाम्पल ऑफ lithium, let me take another color, lithium, sodium and potassium का एग्जाम्पल लेंगे, ठीक है। तो मान लीजिए दिस इज योर न्यूक्लियस and in lithium you have electronic configuration is like this. In lithium you have 2 electrons here, 1 electron in the outermost shell. All right, so this is your lithium. But let's say in case of sodium, what will happen? In sodium, change the color. It's little slow, guys, to erase this. Okay. All right. So when we draw for sodium, here is the nucleus, right? Here we have 2 electrons here, we have 8 electrons here, and we have 1 electron in here. Similarly for potassium, this is the nucleus, 2, 8, 8. I'm sorry, please excuse my these shells, okay. So this is your, let me have a red color. This is your potassium. All right. So what we had here, 2 electrons. Here the electronic configuration was 2, 1. Here the electronic configuration, the electron towards it. So that means the outermost shell will not be under the effect of that nuclear force. Okay. So that means this cloud will be kind of spread out. Okay, this will be kind of spread out. So that is why as we move down the group, the size increases. As we move in group, the size increases. In a period, size decreases as we move. Okay, so this is one of the trend that you will have to remember. Now guys, there will be a second trend that you will have to remember in this case is your ionization energy. Okay, so let's write what is ionization energy. So ionization energy is the energy required to remove the outermost shell from the valence, outermost electron from the valence shell. So if I say, okay, I have lithium. So if I just draw it real quick, this is our lithium, this is our sodium I will draw, and this is our potassium nucleus. It will have 4. Okay, so here what we have, I will just write, I will not draw all the electrons now. So it will have 2 electrons and there is 1 electron. Here we have 2 electrons, 8 electrons and 1 electron. Here we have 2, 8, 8 and 1 electron. So always remember guys, this nucleus attracts, this nucleus, let me highlight it. There is a force which is occurring between this nucleus and this outermost electron. This nucleus and this outermost electron, and similarly nucleus and this outermost electron. So this force is the force which will be binding the electrons, towards, this is the force which is binding the electrons with the nucleus. Okay, so there is a force between this nucleus and the and the electron which is binding it towards it. So ionization energy is the energy which we need to remove this electron. Okay, so in case of lithium, we see the outermost electron is very much close to the nucleus, which means it is tightly attracted by the nucleus. And if we go to lithium, and then we have sodium here, and then we have potassium here, and here the outermost electron, if you see, the outermost electron is far away from the nucleus. Okay, that means it is loosely attracted. So what will happen if it is loosely attracted? That means we need less energy. Less energy to remove this electron. Okay, it is not strongly bound to the atom, but here we need more energy because the electron is tightly bound to the nucleus. So ionization energy is highest, and then it keeps on decreasing as we move down the group, and it will be opposite to this trend as we move along the period, because what happens is, in a period, as I told you earlier, when we move along the period, the electrons are being added in the same shell. Let me show you real quick, and then give me a second. Okay, so let me show you. If we go from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and I will just draw. Here is our nucleus, and here is our, I will quickly draw it. It will be electronic configuration 2 1, 2 2, 2 3, 2 4. Here we have 2 5, 2 6, 2 7, and 2 8. Okay guys, so as we are adding electrons here, where's my cursor? So there are 2 electrons over here. In lithium, there is 1 electron added. So guys, remember one thing. When we are adding electrons, remember protons or neutrons are also getting added in the nucleus. Okay, so which means the shell is same, which means electrons are getting added in the same shell. Shell is not increasing. So if the shell is not increasing, that means the distance from the nucleus is not increasing. And if the distance from the nucleus is not increasing, and number of protons and number of neutrons in the nucleus, they are increasing, that means they will be attracting the electrons with greater force. Okay, so it will be very difficult for us to remove, let's say, 8 electrons. Let's say it's a neon atom. To remove these electrons from this atom, it will be very difficult. Okay, so that means the ionization energy, as we move along the period, it increases. Okay, the ionization energy increases as we move along the period. And how about electron affinity? It is just the opposite of ionization energy. Electron affinity is the affinity, means the love for the electrons. So as we move along the period, the love for the electrons, it will increase. Okay, why? Because let's say, let's take the example of, let me take the example of I just want to remove this, I'm sorry. Okay, Okay, so let's say this is our, yes, today we have a fitness class. So let's say we have 7 electrons. It's a halogen, which is, I'm taking example of this fluorine. So it needs only 1 electron. So it will be needing that 1 electron like anything, right? So it will attract that 1 extra electron and with much force, and that is called, its electron affinity is way high as compared to lithium. Okay, so as we move along the period, the electron affinity of the elements or of the atoms, it increases. Okay, it is the nuclear forces because of protons and neutrons. There is nuclear forces in the center of the, we call them nucleons. Okay, so that is which attracts them. So I talked about all these trends: the atomic radii, electron affinity, and ionization energy. So let me go over it quickly. So as I said, as we move along the period, our ionization energy, it goes up. Electron affinity, it goes up. Okay, as we move along the period, and as we go down the group, our radius, it increases. Okay, so these are the trends in the periodic table that we have just covered. Okay, here we go. So it increases, atomic radii increases as we go down the group, as we move towards the left of. You have doubts, Anuj, please ask your questions if you have any. Okay, and then I will quickly move on to, this is just the start of the periodic table. There is a lot that I need to cover in periodic table, but in 1 hour that is not possible. So maybe I will start a series on understanding the periodic table. Okay, and then we will cover. So I have this pop-up quiz. If you guys are ready, then let's get started with the quiz. Tell me the answer for this. Thank you, Aryan Gupta. Yes, Vijay, give me your doubt. I will answer it. So I will be having a series of videos on the same topic on the periodic table, and then we can discuss. So what is the answer for this question? How many elements are there in the modern periodic table? 109, 99, 108, and 118. The answer is there are 1, 1, and 8. Some of them are natural and some of them are artificial. Next question is, group 1 elements are also called. What do we call group 1 elements? Alkali metals, alkaline earth metals, non-metals, or inert metals. So we call group 1 elements alkali metals, guys. Alkali metals are the group 1, and this is group 2. Non-metals are like they're spread on the periodic table, and the inert metals, we don't have them. Right? All the gold and silver, they're called inert metals because they don't react. Next one. Group 2 elements are called. I just answered that. Group 2 elements are called alkaline earth metals. I just explained. Group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals. Okay, and then we have, these are the number of groups and periods in the periodic table. So if you attended this session carefully, you will be able to answer this question: how many groups and how many periods are there? So guys, the answer is B. There are 18 groups and 7 periods present in a periodic table. Aryan, I'm trying to speak loud. Is it better now? All right, so next question. As we move down the group, the atomic size will, in the group, the atomic size will increase down the group, decrease down the group. There will not be any trend, none of the above. So as I showed you, as we move down the group, there will be an increase in the atomic size of the atom of the elements. Okay. As we move along the period, the atomic size will, just ignore this, increase, decrease, there will be no trend. I just copied that slide. So as we move along the period, the size will decrease. Okay, as we move along the period, I have explained it. So guys, with this, we end today's session. But if you have any questions, if you have any queries, you can find me on Unacademy platform, and my name is Dr. Pooja Sharma. And guys, I teach you guys science on that platform. I teach physics, chemistry, and biology. Everything I teach on that platform. If you want to learn from me, you can be part of my plus group. Here is the code that you can use for extra 10% discount. Okay, the nuclear force, that is called the nuclear force, Anuj, that attracts the electrons, called the nuclear forces. Okay, I teach you guys physics, chemistry, biology, and tonight at 9 p.m. if you are not a plus student, tonight at 9 p.m. I'm a fitness coach as well. 9 p.m. I have a class which is a free class on fitness. Okay, so guys, please come and join me. शुरू से नहीं समझा सकती आर्यन, अब तो टाइम हो गया है ना, आप देख लेना एक बार, और नहीं तो मैं आपको आई विल टेक अनदर क्लास एंड आई विल एक्सप्लेन इन दैट. ठीक है, दिस इज़ वेरी इंपॉर्टेंट गाइज. इफ़ यू want to stay fit, so please attend my this class tonight at 9 p.m. Okay, it is a free class, no subscription required. It is on fitness. Okay, so that is it. Thank you so much. I'll be keep seeing you guys more and more on this platform, and I will see you guys at 9 p.m. tonight on Unacademy's platform. Okay, thank you so much. You guys have a wonderful time. Take care and bye-bye.